Hello and welcome everyone to CyVerse's Fall Webinars. I'm Tina Lee, CyVerse's User Engagement Officer. We're pleased today to host this webinar on Connecting Your Colab with CACAO, presented by my colleague Edwin Skidmore. Before we start, let's just do some quick housekeeping. Please open the Zoom chat window, type any questions there for Edwin, and I'll let one more person in. He'll answer your questions after his presentation, which is a little bit shorter than 30 minutes long if the demos all go perfect. As usual, we'll record these webinars and I'll post them onto CyVerse's YouTube channel as well as on our webpage. And now I am pleased to introduce my colleague, Edwin Skidmore, who's our Director of Cyber Infrastructure for CyVerse. Edwin has been with CyVerse since its inception in 2008 and manages the cloud native team. In 2010, Edwin's team introduced CyVerse's first cloud compute resource called Atmosphere, where researchers and educators could launch virtual machines with a few clicks, enabling a whole generation of scientists to discover the benefits and ease of working individually and collaboratively in the cloud. Today's webinar is on Colab and CACAO and presents a handy new way to continue to do cloud native work using free resources in both CyVerse and Google. So welcome, Edwin.
Thank you, Tina, and thank you everyone for joining today's webinar. And so today I'm going to talk about how we can connect your Google Colab notebooks to other clouds using CACAO. Or as I like to call it, Colab gone rogue, hooking up to the cloud of your choice. So as kind of the logistics, I will briefly talk about what is Google Colab, what is CACAO, and why the two are a really good combination together, and then give some demos of how this all works. So just to do a quick virtual poll, can everyone who's used a Jupyter Notebook or know what a Jupyter Notebook is use a thumbs up in Zoom? Cool. It sounds like most people have had experience or know about Jupyter Notebooks, but for those that maybe don't know what Jupyter Notebooks are, so they've been around for a while and fairly common in many disciplines, including data science, computer science, education, research, and many more. And these are basically documents that allow narrative text to accompany code, equations, images, and other things. And so by themselves, without any compute, they can be very informative, but combined with compute and storage resources, they become a fantastic interactive document that can execute code in real time. And you can run Jupyter Notebooks in any environment, including your laptop, your desktop, in containers, in IoT devices, on HPCs, and even in the cloud. And of course, one of these is Google Colab. So just as another quick poll, can you do another thumbs up if you've used Google Colab? So great, it looks like some people haven't used Google Colab and some have. So, so essentially Google Colab is a hosted Jupyter Notebook service. Its claim to fame is that it's very simple to use and requires no setup. And it provides free resources or nearly free resources to compute resources such as GPUs and TPUs. And so, as I mentioned, it's very easy to use. You essentially import your notebook, or you could go to the site like Open in Colab and generate a badge so that you can easily share it out. The notebooks are in Google Drive, so it makes it really easy to share it with others to edit. It used to support live editing and as a form of collaboration, but they've since removed that, the live editing part, but you can certainly do editing within Google Drive still. And as I said, there is free access, so they provide a free tier, but those come with certain caveats if you're not paying for the premium service. So if you're using the free tier, it is limited resources, and you may even actually be, your processing may be interrupted for those premium members. Your storage quota when running a notebook is dictated by, again, like if you have a free tier or if you're using a paid version. If you're in the free tier, you also have time limits, so 12-hour time limit. Though if you're paying for Colab, you still have up to 24 hours for your hosted runtime. You can break out of those runtime limits by using a dedicated Google Cloud VM. And then there are certain features that are disabled in the free tiers, such as the terminal and file browsing. So this is where CACAO can help with those restrictions and those quotas. So CACAO is a cloud automation, continuous analysis orchestration platform that we developed here at CyVerse. And so essentially CACAO is a broker that sits between users, whether you're a researcher or an educator or a research software professional. And then it helps create resources to any number of clouds. And it does this by using what's called templates or recipes, which creates these clouds for the users. So templates can be as simple as creating a single virtual machine to creating, complex resources like a Slurm cluster, which incidentally, we have one that creates a Slurm cluster on demand for courses. It's was provided by the Canadian Digital Research Alliance. So in this fashion, we've also created a Google Colab template that will tap into resources like Jetstream 2 and AWS. And just to show you how this works, I'm going to talk a little bit about how Colab can connect to your Jupyter Notebook to compute resources. So one option is if you upload a Jupyter Notebook into Google Colab, you have one option is to use what's called a hosted runtime, or you can use a custom VM in Google Cloud. And once that's done, then you can start executing the code that's in that Jupyter Notebook. Another option is launching a Jupyter runtime locally on your laptop or desktop. And you then specify what port is running on your laptop or desktop that's running that Jupyter runtime. And then another option is then to use CACAO. So how CACAO works is that you can launch resources in AWS and Jetstream 2, and then configure Colab, your Jupyter notebook, to use that virtual machine that's launched in Jetstream or AWS. So some of the benefits of using CACAO with Colab is that you can break out of those free tier quotas and restrictions, so you won't be limited by time or preempted because you're not a paid member. You won't have necessarily quotas that are restricted by Colab, though you may have quotas if for certain clouds, depending on the size of the VM that you launch in, let's say, Jetstream 2 or AWS. And then you might have access, and other reasons is that you might have access to free resources already as a researcher or educator. You can use Jetstream 2 and now recently that's come out is the Nair Pilot Classroom if you're doing AI type of education. And then some projects already have access to AWS. They might have funding or part of their funding is to use AWS. So you can tap into these existing resources. And then another benefit of using CACAO specifically is that CACAO can provision other resources, other software stacks, as I mentioned, and you can use those resources within your Jupyter Notebook. I won't go into these, in this webinar, but maybe that would be for a future webinar in connecting, let's say, a Jupyter Notebook to your Kubernetes or Slurm cluster that's created by CACAO. So now I'll go ahead and jump into the demos. So the first demo is, let's say, your standard Jupyter Notebook. This one is provided by Colab already. It doesn't do anything fancy other than do some simple arithmetic. But if you notice, you can, if you try to do, like right now, it's not connected to a runtime. But if you want to use certain features, it does tell you that you have to use, sign up for your premium or the pro. So there's no file browsing until you connect. Oh, I was going to show. So one of the options is you can connect to a hosted runtime or connect to a Google Cloud VM. So because I clicked on file browsing, it automatically launched a runtime for me. So that's cool. So you can determine where you're running your notebook now that is connected to a runtime by just hovering over this RAM disk, these spark lines, and it'll say, "Hey, you're running on a Google Cloud Engine VM of some sort that's Python based." And so now that it's connected, I can go ahead and step through the notebook and run these things. So obviously this is a very simple notebook. It's not going to take a long time, but if you were doing real data science or real, machine learning, these could take a very long time depending on your data set. And if you're using the free tier, could be interrupted by paid Colab users. So you should always disconnect and delete the runtime if you ever launch one. And so this is where, again, CACAO can help with, extending your Colab to existing resources. So this is CACAO running on Jetstream. It's at cacao.jetstream-cloud.org. I'll just kind of briefly walk through the interface of CACAO. So once you've connected, once you have an allocation in Jetstream 2, which is through the Access CI program, you can see, how much your utilization is. So I'm on a few allocations in Jetstream 2. And these are templates. So in the template section is where you can browse what you can create in Jetstream 2. So as I mentioned, you can create a Slurm cluster. We have templates for LLMs. You can launch VS Code. You can launch a Jupyter Hub for a workshop, which we'll have another webinar later in the fall to go over, to teach folks how to use CACAO for using workshops. In any case, one of the templates is a Colab runtime. So I'll just step through launching one. I'm going to launch it in this project. And then I'm going to give it a name. So what this will do is launch a virtual machine, which you can then use for your Colab computation as well as your storage. I'm going to give it a password. And I'll show you what the password is used in a second, but in a moment. So in here, this field is you're selecting the size of the VM. So, and then there's a little guidance about the size that you'll need to run Google Colab. So the reason why you need at least 60 gigs of storage is that what this template will do is after launching a VM, it will launch a Docker container that's from Google that is specially created to run Google Colab notebooks. So you have to use something like a M3 medium or appropriate size. The other thing you can select is if your notebook requires GPUs, you can certainly select any of the GPU sizes. So in this case, I'll select this. And then one other piece I want to show you is if you need, larger sizes, or if you wanted to run let's say a smaller size that has smaller disk by default, but you want to increase that size, you can actually set up, a VM and create an arbitrary size up to your quota in Jetstream 2. So if I wanted like a 0.5 terabyte disk and my quota allows it within Jetstream 2, I can go ahead and create that. And then that's it. It'll once I click deploy, it will deploy and it's launching. So for GPU instances, it may take several minutes. So I've already created a GPU VM so that I can continue with the demo. In this case, this was clicking into it. You can see information about this GPU, but one of them that will be important is this proxy URL. So if I click on this, it will go to a page that will provide instructions on how to connect your Google Colab to your to this VM. So the password that was set when I launched this deployment is going to be used here. And so this is the page for the instructions. So in order to connect the Google Colab to this VM, you actually have to use SSH tunneling. So on a Mac, you can use Terminal. On the PC, you can use any number of tools. I use WSL2, but there are other. You can also use PowerShell. So here is WSL2, and I can copy this to do the SSH tunneling. So once that is connected and you've set up the tunnel, you can now connect to your Google Colab notebooks. So I have a couple that have already been loaded up onto my browser. So one of them is a deep learning with the Tecto notebook. So Jeff Gillen, who's also on the at the U of A's Data Science Institute, he gives geospatial workshops, and this is one of the notebooks he's created for the workshop. This essentially does convolutional neural network for object detection, and so he has made a link to Google Colab. So if I were to click on this link, which I am, it automatically puts me into Google Colab for that notebook. And so, so right now it's not connected, but we'll go ahead and connect to a local runtime. So that's actually pre-filled. Oops. And then if you go back to the instructions, if you scroll down, it'll say, enter this text as the URL. Oops. So I'll go ahead and copy that and put it into this URL, and I will connect. So once I do that, it's working, and then it'll show that it's connected. So you know it's connected and not into the Google Cloud runtime is if you hover over these spark lines, you can see it's connected to the local Python environment on port 8080. So, and also you can see that the RAM is 30 gigs of RAM. That CPU, that's the RAM dedicated to the CPU, not the GPU RAM. And then this is the disk size that's reporting from that virtual machine. You can also click on this now. So remember, this was a premium feature when you tried to access the terminal. And now I can get access to terminal. I can see what data is on this in this particular virtual machine. And then you can also, because I launched a GPU instance, I can run the NVIDIA SME command, which I'll brighten up the screen. And you can see that it has 10 gigs of VRAM. And then the one thing it doesn't show you when you're in this, when you're in the Jupyter Notebook is you don't see what processes are running necessarily, and I'll show you that in a second. But if you were to go back to the original terminal, you can also run NVIDIA SME. And it doesn't have anything running right now, but I'll show you when I do run it. It also reports that you're running on an A100. Technically, I'm running on half a A100. So in Jetstream 2, you can select fractional GPUs, so a quarter, half, 3/4, and you can even request a full size. But for this demo, I won't need all of it. And so now I can go ahead and run. I'll go ahead and run all. So this is going to take a while. But the nice thing with using this way of connecting your Google Colab is that you can actually run multiple notebooks using the same connection. So I have another, while that's running, this is going to take some time because it has to do some training. I'm going to go ahead and launch another notebook. In this case, I'm going to use Deep Lab Cut, which essentially does tracking for animal, animal features. So you can see examples of videos that have been processed through Deep Lab Cut and what it tracks. But Deep Lab Cut also has opening Colab notebook. So I'll go ahead and click on that. So again, this is an example. And I will connect to the same virtual machine to connect this Colab. Now click connect. And now we're connected. So before I run the notebook, I'll just show you something about the Colab. So when you click on, if you're in another notebook that's running the same virtual machine, you'll notice that you can still see the same file system. But if you open a terminal in one thing I noticed, it disconnects you from another, just to kind of keep that in mind if you have multiple notebooks running. But I'll go ahead and run this notebook. And in here, I'll kind of just show NVIDIA SME. Notice now you can see that there's some VRAM being used, but you don't see the processes here. So don't be alarmed that if you're thinking that your processes aren't running, because if you were to run NVIDIA SME on the in the VM itself, on the terminal, you'll see what's running. So right now it doesn't show the second process because it hasn't hit upon the training portion of the Deep Lab Cut. But so it's running, it's just doing the installation. Yeah, so I think that's about it for the demo. And then the other thing I'll show you is we also have this connected to AWS. So you can see here at CACAO.CyVerse.ai, this is currently only available to University of Arizona folks. But you can, when you do a new deployment, you can do Colab runtime in AWS and step through the process in a very same way as I did for Jetstream 2. And once you have that running, the only difference is that we don't have the proxy set up, but for now, but you can go over here and connect to it through the IP address, and you get the same instructions to do that. So let me see if the second process is not, no, it's not there yet for the training. Yeah, so I have, just as an example that these finished to completion, I did this, I already ran these notebooks on a different Colab virtual machine, and you can see that it processed, after the training, it did identification of objects within the image. And then over here, well, it finished to completion and ran, and well, it doesn't show up there, but I downloaded the videos, This was the original. You'll see. Oops. So that was the original image. And then if I click on this one, this was the image of what it identified for the mouse. So you can, in Google Colab, you can download your files using the file browser. Oops, that one's disconnected. And I'll show you this one. So if you use the file browser, you can then, essentially click on or select a file and then download, which will then pop up a dialog so you can download it. So these are all, all these files are on the VM itself. So if you need more space, you can either set a custom disk space size, as I showed before, or you can launch a larger image that has more space and more CPUs. So that's it for the demo. Are there any questions? Oh, there are.
There is a question. I'm going to read it in so it's in the audio. Can you access the data stored in CyVerse within Colab using CACAO?
Yes. So there are it's not set up by default, but there are many client tools that you could use. You can use within the notebook environment. You can download Go commands. You can install. You can also use WebDAV as part of the Jupyter Notebook. But it's not installed by default, but it's really easy to get the tools in place. So if you have any questions about that, we can work with you about what's the best way, depending on what your notebook is. We can also create custom images too. So the one I'm using currently is the Google Colab one, but we can certainly swap that out for other images that have tooling that's already installed as part of the image.
Thank you. Are there any other questions for Edwin? I'm checking the chat. Or feel free to unmute yourself if you'd like, since there's a small group of us. Okay, Edwin, thank you so very much. That was really helpful and very clear, and I like the new layout here that we've gotten for presenters. So please do join us next for our next webinar, which will be on October 11th. And in the meantime, thank you very much, Edwin. Thanks everyone for joining.
Thank you for everyone.
Thank